In this video, we're going to be talking about how the focal length can change for a lens as the temperature changes. And so the simplest idea is to have a thin lens. And if you have a very thin lens that focuses light to a point, light coming from this direction, you'll have the focal length, f. Now that focal length will change with temperature. And there will be two contributions. So if we think of that focal length changing a particular amount called delta f, that change in focal length, delta f, is equal to delta times f times delta t. So delta is the coefficient of thermal defocus. F is your focal length, and delta T is your change in temperature. Now if we take a closer look at delta, delta is a combination of two, or actually three material properties. So delta is defined as the thermal expansion coefficient of the lens material minus dN dt, where n is your index of refraction, and that times 1 over n absolute, which is your index of refraction, minus 1. So your dN dt, your n, and your alpha are all material properties. So thermal expansion coefficient, dN dt is the change in index of refraction with temperature. And this is the refractive index. This term looks very, very similar to the change in length of a material due to thermal expansion, which we'll get into a little bit later.